Welcome back to a new session. The course Introductory Concepts on Digital Computing offered by Swayam comes to an end. This is our last session. During the entire course time, you were introduced different concepts and techniques used in digital systems and learned to design some important digital circuits. How the various logic functions that have been studied during the course can be used to design a digital system. Here I introduce you a process control system for bottling vitamin tablets. The reference is taken from the book Digital Fundamentals 11th edition by Thomas M. Floyd. You can use this book for further references. Process control system. Let us start. Before moving on to the system requirements, let me just describe you what is a process control system. Process control is the ability to monitor and adjust a process to give a desired output. It is used in industry to maintain quality and improve performance. An example of a simple process that is controlled is keeping the temperature of a room at a certain temperature using a heater and a thermostat. In this example, when the temperature of the room is very low, the thermostat will turn on a heating source until the temperature reaches the desired level. Once it reaches the desired point, the heater is turned off. As the room cools, this process repeats itself to keep the room at the desired level. To control such processes, we need an arrangement of several physical, digital and electronic components. The components continuously measure one or more aspects of the process and then changes those aspects as necessary to achieve a desired process condition. This session illustrates you with a process control system, tablet bottling system. The goal to achieve is to fill vitamin tablets to empty bottles. There are certain requirements to be satisfied while running the system. The important functions are encode the input received from a keyboard, keep or store the count of input and total number of tablets filled in the bottles, then counting of tablets, display the number of tablets, check whether the bottle is filled or not. The last one, if the bottle is full, place the next empty bottle. To accomplish these functions, we need some physical or mechanical components. The components are large funnel type hopper with a narrow neck, smooth movement of bottles on a conveyor belt, keypad to feed the input, that is the number of tablets, then sensor for precise counting, then display board to exhibit the number of tablets and place the empty bottle when previous bottle is full. The different digital circuits in this system are encoder, register, code converter, comparator, counter, adder, decoder, multiplexer and demultiplexer. Now, let me explain you how the tablets are bottled and how this system is automated with these circuits. The very first operation is giving the number of tablets to be filled in a single bottle. We have to input the number of tablets to be filled in each bottle. This is entered through a keypad. This number is to be stored somewhere so that the filling system can check the count of tablets after filling each tablet. How is this performed? No mechanical components can remember the number or add the number as each tablet dropped into the bottle. So, we need digital components. The decimal value entered at the keypad cannot be sent to any of digital circuits. So, we need to encode the input data. Here we introduce one of the circuit we learned, encoder. What is encoder? The encoder converts information such as a decimal number or an alphabetic character into some coded form. This number is to be stored somewhere so that it can be checked against the number of tablets dropped into the bottle. This is to check whether the bottle is full or not. How do we store? Here we introduce the next circuit, register. What is the function of a register? A register is to store the groups of binary bits. Do you remember the register circuit? It is formed by combining several flip-flops. Actually, flip-flop is the basic element of storage. So, the register stores the number we entered through the keypad. If we need to display this count on a display board, that can be done only by decoding the data. Register stored the data in binary. So, to display the equivalent decimal number, we use a decoder, the next digital circuit we learned. The decoder gets the coded information such as binary number into a non-coded form such as decimal form. So, the decoder takes the binary value from the register, decodes it into decimal form and display it on the monitor. So, as we enter a number, it will be displayed on the monitor. What I described so far is the first phase of this system. Now, let us turn our attention to the funnel type hopper. This hopper has a narrow neck and only a single tablet can be dropped to the bottle through this, that too only when the valve is opened. The empty bottles are kept on a conveyor belt and it is arranged in such a way that the bottle is placed straight below the hopper neck, so that the tablets are dropped directly to the bottle. Also, there is an optical sensor that detects each tablet that is dropped into the bottle and produces a pulse. Here we start the second phase of the system. When a pulse is generated, that means one tablet is dropped. Now, we have to increment the number of tablets filled. Also, every time when a tablet is dropped, we need to check whether the bottle is full or not. How do we execute these functions? As a pulse is generated, it goes to a counter. Do you remember the function of counter? It counts events represented by changing pulses. It remembers the present value so that it can go to the next higher value. Here the counter keeps the number of tablets dropped in the bottle. So, each pulse from the sensor makes the counter be incremented by 1. This counter value is moved on to two circuits, an adder circuit and a comparator. Why do we need a comparator here? It is to compare the number of tablets dropped in a bottle with the input value given from the keypad. Because every time when a tablet is dropped into the bottle, we have to check whether it reached the maximum. If yes, the bottle is to be shifted. This is done by the help of a comparator. In the first phase, the register stored the number of tablets. That number is given to a magnitude comparator through a code converter. So, here I have mentioned two more circuits. What are they? Code converter and magnitude comparator. A code converter changes one form of coded information into another coded form. The basic function of a comparator is to compare the magnitudes of two binary quantities. It determines whether two numbers are equal or not. So, the code converter converts the data stored in the register to a binary value and send it to input A of the comparator. Comparator has two inputs A and B. So, A has the number of tablets to be filled. Input B of the comparator is given by the counter as each tablet is filled. When the counter is incremented, the comparator also gets its input value as n. This is the case where both inputs of comparator becomes equal. When A equal to B, the output of comparator goes high. It indicates that the bottle is full. The output of the comparator is connected to the valve of the hopper and to the conveyor belt. So, when it is high, the valve gets closed. So, no more tablets to the bottle. At the same time, the high signal from the comparator causes the conveyor belt to move and an empty bottle is placed below the hopper. This is how the bottles are filled one after another. When the bottle is placed in the right position, the conveyor control issues a pulse. This makes the counter to reset to 0 and then the B input of the comparator will become 0. This causes the comparator to produce a low output and hence the valve is opened again, starts filling of tablets in the next bottle. This is the second phase of the system. Next, the third phase. It is to display the total number of tablets filled in the bottle. It is managed by the help of few other digital circuits: adder, register, decoder, multiplexer and demultiplexer. As the counter increments, the value is also sent to an adder as input A. We know that adder is a combinational circuit, it cannot store the previous value. So, it is stored in a register connected to the adder. This register content is sent as the B input of the adder. So, each time when a new tablet is filled, counter gets incremented, adder gets the counter value in its input A and adder gets the current register value as its input B. So, at present adder input A has the counter value and input B has total number stored in the register. Adder adds these values and the sum moves to the register. So, the new value at the register will be the cumulative sum. Hence, the register always contains the running total of tablets filled in the bottle. Register has an upper limit value that can be stored. When it reaches that maximum, it is sent to a multiplexer. The multiplexer circuit is a logic circuit that switches digital data from several input lines onto a single output line. And here it is used to convert the binary from parallel to serial so that it can be sent to a demultiplexer. What is the function of demultiplexer? It switches digital data from one input line to several output lines. Here it converts serial data to parallel binary bits. This can be stored on a storage medium. Thus, the total number of tablets filled in the bottles is stored on the computer. Hope you understood the automation process of this tablet bottling system. This is just an example that applies the different circuits we have learned throughout the course of study. Let me conclude now. The entire course was a journey through digital principles and digital circuits. I am sure that it will help you to be more curious about digital computing. As we move with digital revolution, it is essential to understand these concepts and techniques. Thank you all for joining us. Wish you all the best.